You can go into the page 44 and you can find the file that says worksheet 1, and this would be worksheet 1, and then eventually we'll get to worksheet 2.
Because I'm like, okay, I'm going to do math now, and then I started playing it, and she got mad at me because she thought I was lying to her.
All right, glad I could. Canvas 4.4. There you go. Look at the page or the module where you can find 4.4, and then you can find. It should say worksheet 1, worksheet 2.
Do I like download something else in a PDF to be able to write on it?
Let me. You need to be able to graph this. Let's talk through it. What's the center line of the wave? What's the center line of the wave? Y equals 0, right? So that's right down the middle here. Y equals 0. When I look at this, remember fireproof form looks like this thing right here. Y minus K over B equals the sine of the quantity X minus H over A. Now, if you look at this, let's say I write that in fireproof form. That would be something like Y minus 0 over 1 equals the sine of X minus 0. Whoops, sorry, off screen there. X minus 0 over 1. Try to get a parenthesis in there. Sorry. Okay? In other words, H and K. What are H and K in this particular problem? They're both zeros, right? So the HK is 0, 0. Whoa, why did I put 10? I don't know. The word phase shift has an H in it. That's your H. 0. The word vertical has a K in it. So that's your K value, right? All right, now, where is that spot? Obviously, that's the origin. Now, several years ago, I had a student that said, he said, I remember that sine goes through the origin, and he told me how he remembered it. So I'm going to share it with you. Now, this fellow must have been pretty religious, because the phrase that he used to help him was this one: original sin. Now, why did he use that phrase, original sin? Because he thought of sine and the origin. I didn't come up with it, folks. This other kid did. But I thought, I'd pass that along to you if that would help you to remember that sine goes through the origin. That is point number 1 on our graph, at least for the cycle that we're drawing. Since we have not done any changing on the horizontal, right? No scale change on the horizontal. What's the period? How long should it take before it starts over again? 2 pi. So that means that point number 2, where the cycle's starting over again, is over there. Where do you find point number 3? Where did I teach you to find point number 3 on the sine wave? Halfway in between, right? So right there is point number 3. Point 4 is between 1 and 3. But I need to know the amplitude. And since there's no change on the vertical, no scale change, or no stretching or shrinking, what's the amplitude? Still a 1. So if I want to find point number 4, I go halfway in between 1 and 3, and I go up 1 unit to find point number 4. Point number 5 would be between 2 and 3, using the amplitude again to go down. So 1, 2, 3, 4, 5. What's the question? Oh, I heard something over here. Yes? What? Okay. Now, suppose you are not as talented as me. Not that I'm talented, because I'm not when I'm talking about art drawing. Okay, not good. Okay, but let's just say you are drawing this. You've identified your 5 dots as best you can. And you're going along, and you went over the top of your point. Okay, I think we can forgive that. Okay, I'm not going to die there, all right? So just do the best you can as you're drawing this. Okay, and then put your arrows on the end. Now, the unforgivable thing would be to draw your arrow past the max. I mean, it obviously is unreasonable, right? That we're going past the maximum. That is not something you will survive. Okay, the red pen of death shall find you and take points away from you. Okay, and I don't want that to happen to you. Okay, let's see here. What's the minimum? -1. What's the maximum? What's the range? -1 to 1. Brackets or parentheses? Brackets. Okay. -infinity to infinity for my domain. Should I put brackets or parentheses? What happens if I put brackets around it? It's wrong, and the red pen of death shall find you. What's the second thing that'll happen to you? You shall be thrown out of every party in America. Right? Because you're trying to tell me that you can grab infinity and -infinity. Okay? Ain't happening, folks. So, make sure these are parentheses. How about the asymptotes? Come on, I need more than this. Asymptotes, what do we got? What are we thinking? Lines that it gets closer and closer and closer and closer and closer to, but never touches.
1 is -1?
Are you talking about vertical or horizontal or what?
Horizontal.
None.
Basically, I was talking about the maximum.
Yeah, and there's no, it'll actually come up and touch that point and leave, so that's not considered an asymptote. Okay? To be a horizontal asymptote, remember that means you're talking about end behavior and getting closer at infinity or -infinity to some value, and clearly we are not talking about anything that gets close to something because it's going back and forth, back and forth, back and forth. Never gets close to one particular value. Okay, you try this one. What would fireproof form look like? Wouldn't it be y over -1? Therefore, we know what's going on with this. It's reflecting across what? Across the x-axis. Yeah, like that you remembered that. Cool. What's going to happen to the x-intercepts? Nothing. You're right. They don't change. Okay? So that's good news. All right, you try to graph it.
I'm using a mouse.
I love touchscreen though, so I can just sit here and do my writing.
I tried, but I wasn't that accurate. I couldn't read it, so I went to mouse.
That's fine. That's fine.
But
So,
the lines aren't accurate.
what's your center line of the wave? Still y equals 0. Okay, that's my k value right there. What's my phase shift? Now, phase shift, remember, that's your h, and that is how much left and right you have shifted the graph. And I can tell that by looking inside here to see how much it's been subtracted or added to. Have they added or subtracted anything to the x? No, so that is 0. So we're starting at that location 0, 0. What's the period of the function? Still 2 pi. They haven't changed that at all on this one. So we got point number 1, point number 2, point number 3, halfway in between. Okay, now, because this has been flipped upside down, where's point number 4? Still between 1 and 3, but we have to go down, right? There's point number 4. Point number 5 is up here. That's because of that whole reflection idea. And you're coming down and then coming back up, and hopefully I do this to the best of my ability. So I still have a minimum of -1 and a maximum of +1, and my range is still -1 to 1. Oops, sorry, bracket, and my domain still -infinity to infinity parentheses. Amplitude, still 1, period, still 2 pi. So none of that changed. Asymptotes, none. Amen. Thank you very much. Tangent is the only one that has. Now, you'll also find in the future that cotangent does too. But we haven't talked about the reciprocal trig function graphs yet. Yeah, we just need to work on the simple ones. Yeah. Okay, I totally understand. Okay, so this is the way the equation's going to look when you're given the equation, y equals sine x plus 2. So if you put it in fireproof form, it'll kind of look like that. If you need some more, that would be y minus 2 over 1 equals sine of x minus 0 over 1. I mean, if you need me to give you more details on fireproof form. But, so really, what is the center line of the wave? It has gone up to y equals 2 is my vertical shift, right? That's my k value. There's been no phase shift whatsoever on this. We haven't gotten to a phase shift at all. In fact, I'm not sure we will get to a phase shift on any of the ones today. I'm just worried about vertical shift, and then we'll talk about stretching and shrinking the others. Okay? So, what's my amplitude? Amplitude. 1, what's my period? Still 2 pi. Plot your values, and we'll see if we agree. We got some here and here. 2 pi units later. Halfway in between, we got 1 up and 1 down. So we can graph our wave and hopefully, oops, disconnected for some strange reason. Oh my goodness. Gee whiz, this is terrible. Let's try this again for all the fans at home. Hopefully you got a picture that looked like that, or something like it. Okay. What's your min? What's your max? What's your range? Use your min and your max to find your range. Okay, any questions on that one? I shall move to another. I'm gonna... What? Really? Yes. Okay, question 5. Whoa. Yes, I skipped a problem. I don't care. All right, now, center line of the wave. What's the center line? Still y equals 0. No vertical shift has occurred, right? That's my k value. Phase shift, still 0. Haven't done any shifting back and forth. So hk still at the origin. Now, when you put this in fireproof form, you see that something's going on. What's going on to the y's? That's a vertical stretch. by 2. So, what does that change? Yes, I skipped number 4. I skipped number 4. We're on to number 5. Changes amplitude. Does it change the period? No. So the amplitude is now what? 2. Now, if you're one of those people that needs some kind of cool formula to memorize, it's the absolute value of the letter B. Now, why is that? Why do I have to take an absolute value? Because it can't be negative. Amplitude is a distance. We do have negative multipliers, but we will not have a negative amplitude. Okay. What about the period? 2 pi. Nothing has changed about the period. You can see right here that it is still x over 1. There is no change on the horizontal. We haven't gotten to one of those yet. So, point number 1, point number 2, point number 3. Where's point number 4? Pi over 2, and then I have to go up 2 units. Right, there's point number 4 because I had to use the amplitude, and point 5 between 3 and 2, but you had to drop down 2 units below the center line. So we're getting a wave like this. And of course, you know, you're thinking min, max, range. Those things are pretty reasonable from -2 to +2. Any questions about how we graphed that one? Okay, so if I divide by 1/2 on both sides, I see that we have what's going on to the vertical. Ah, that's a vertical shrink by 1/2. Everything else is staying the same, right? My center line hasn't changed. My amplitude hasn't changed. My period hasn't changed. Or has any of that changed? Did I mark anything down wrong? Ah, the amplitude is not 1 anymore, folks. What is it? It is 1/2. So we've got that point, and that point, and that point. So 1, 2, and 3 were the same. Point 4, I only go up how far? I only go up 0.5 units. And 0.5, I go down 0.5 units. So we have this really shallow looking wave. Any questions on how we did that one? All right, so that one, let's see, that's nothing terribly new, so I think we should probably skip that one. If I have time, I'll come back and do that one. Let's go to number 9. I definitely want to get to number 9. Okay, so this is how it might look when it comes on a quiz or a test. Sine y equals sine 1/2 x. Do you understand that's the same thing as this one at the top? That one is kind of more in fireproof form. It's the idea that, you know, multiplication is the same as dividing by the reciprocal. Same thing we taught you in junior high. All right. So, yes. Oh, it'll probably start right there. You'll have to do algebraic manipulation to put it into fireproof form if you want to know what A, B, H, and K are. And yes, I would recommend that. We will get some more difficult questions as we go, where you'll have different numbers for all four of those things. And yes, knowing what A, B, H, and K are is kind of important. Okay? So how about my center line? What's my center line? Okay, still kind of boring, right? Y equals 0. All right, that's my K value. Phase shift, nothing there. Haven't done any subtracting or adding to X. So we know that we're still starting out at the origin. Let's see here. This is a horizontal. Is that stretch or shrink? That is a stretch. Why do I know it's a stretch? Because it's greater than 1. It's greater than 1. If it was less than 1, it would be a shrink. It's important to understand that it's in that denominator, that you're looking at that number. So, what is this going to change? If you take the whole graph and stretch it by 2, it's going to change the period. Now, if you're one of those fans of having some kind of formula to memorize, it would be 2 pi times the absolute value of A. Because the original period is 2 pi, and I'm stretching it. So, what do you get? 4 pi, right? Because you multiplied it by 2. You stretched it by 2. So, if this is point number 1, point number 2 is all the way over here. Where's point number 3? 2 pi, halfway in the middle. Amplitude. 1. That has not changed because we didn't do any vertical stretching or shrinking. So, when I'm finding point number 4, it's halfway in between and it's 1 unit up. And point number 5, halfway in between, 1 unit down. That's your picture. It was horizontally stretched. Any questions on that? Where was the one? Oh, yeah, 10. 10's good, and then we'll keep going because This is what you're going to be given. Y equals sine 2x. I need to show you some algebra because if you don't do this, I am afraid you will make mistakes. Okay? Suppose you were looking at 2x. Everybody in the room should know that 2x and 2x over 1 are the same thing. I see a lot of people I have over the years that get confused about what's going on with the horizontal scale change. And I know how a lot of Algebra 2 teachers like to show it to you, and frankly, I was one of those teachers until a kid showed me or reminded me of something, and then it changed my world. See, I want to change this from 2x to 1x. Can you tell me what number I should multiply by? How do I go from 2x to 1x? What should I multiply by? I should multiply by 1/2, better known as the reciprocal of 2. Now, I also learned, back in my days with fractions in junior high, that if I do something to the top of the fraction, I have to do the same exact thing to the bottom of the fraction. So, what do you get when you multiply 1/2 times 1? 1/2. So y equals sine 2x is the same exact thing as y equals the sine of x over 1/2. Now, why the heck would I want to write it like that? Because I can tell you, when I see a 1/2 in the bottom, is that a horizontal stretch or shrink? That's a horizontal shrink. By 1/2. So when I go back over here, wrong one. That's why in the fireproof form it looks like this. Now, I know that every math teacher in the world thinks that you should be able to look at this 2x and go, oh yeah, multiplication by 2 is the same thing as division by 1/2. But I have experienced over years of time that you don't remember that fact. So I suggest you take this fraction, 2x over 1, and multiply by that reciprocal on the top and the bottom, and I know that all of you will get it right. So if we're doing a horizontal shrink by 1/2, what's the period? Only 1 pi. Right? Because we did the 2 pi times the absolute value of 1/2, and that's how we got 1 pi. The amplitude is still staying the same. The center line still staying the same. H and K still staying the same because none of that's been changed. So, we're here. That's point number 1. Point number 2, pi units later. Because that's where it's going to start over again. 3's right here. Halfway in between, I'm going up 1 unit. Halfway in between, I'm going down 1 unit for my point 4 and 5. And then I can draw my change. Okay? I know we're running out of time here. Can you describe to me? Let's go down here. Can you describe to me where the center line of question 12 is? The center line of question 12. That is y equals +1. And we shall continue this at a different time.